Guys, the screen is displaying. Okay, it is nothing but traces. Okay, traces means we have considered that what are the material should be taken for the trace. Any guesses, guys? Guys, did you hear me? Hello. Sorry, guys. First of all, here traces or a copper trace, which means the nothing but a composition and placement here. Here we will selecting which material for traces. Any guesses?
Copper.
Yeah, it's copper because it is a highly conductive material. Okay. At the same time, why we are using copper means it can be easily transfer the current from one component to another component. Okay. Or mainly for the signal transmission. Next, at the same time, a location where the copper plate should be placed. It's on top, bottom layer, or middle of the PCB. Okay, based on the complexity. If the design is simple, means it should require one single layer. It should be if it's complex, means it should be require the multi-layer board. So it's also the location should be there. Functionality of the traces. We also know as that what is the functionality means the traces are mainly used for the signal and power transmission and the connecting of the connection of the components. Okay, here there is any doubt for you, guys? If you have any doubts, means you can
No
move on.
doubts. No doubts. No doubts.
Other than Srikanth, anybody can answer?
What is mean
No,
functions?
sir, no doubts. Yes, carry
Yeah,
on.
yeah, Gopal, tell me.
What's mean by function? Can you please explain?
Functions mean nothing but traces. I also mentioned you before. Traces are the copper tracks, okay, which carries the signals one component to
Signals.
another component. You can see that while drawing the layout, there is a red color
Red color.
connecting.
Yes,
Yeah,
yes.
yeah.
Yes.
That is a
Trace.
trace. Okay. It is the function of the trace is to share the signal transmission from one component to another component or top layer to bottom. Okay. Okay. Connection of components. The traces act as a bridge between one component to another component. Okay.
Okay, okay.
Yeah. Okay. Let us see the next. Third one is a characteristics of trace. Okay.
Okay.
In this, you can see that what are the characteristics mean width, spacing, and length. Okay. These three are the major things which is essential for the trace. Guys, any guesses for width? What is the role of width in the traces? The width of the traces is crucial in determining its current carrying capacity and impedance, resistance to the signal flow. Okay, I already mentioned that. uh, I show give you example like water flow. Oh yeah, with wider width, lesser width. Yeah, if the resistance,
Yes.
yeah, that is the main concept of width. Other than spacing between the tracks also important to the avoid electric interface like crosstalk and short circuit. Guys, spacing means if you carrying the signal with two different traces. Okay, guys, you can understand.
Ah, yes, sir. Yes.
Carry?
Yeah, you can carry the
Sir, I
two.
have not understand that.
Satyamurthy,
Spacing,
okay.
I have not understand.
Okay. Spacing means you have carrying two signals, okay, in two different traces, which is placed nearly, okay.
Okay.
For example, for a national highway, there is a two lanes, yeah, right, for a
Yeah.
straight and a reverse direction, okay. At
Okay.
the same time, the center meridian, the where the grasses are placed,
Yes.
which separate, yeah,
Yeah,
that is
okay.
compare that is a spacing, okay.
Yeah.
Okay, that is a spacing.
Okay.
The two highways are the traces. Okay, the if
Okay.
there is a certain predefined spacing between the traces should be fixed. Okay, in case
Okay.
you are varying the spacing, for example, your traces should be nearer to the predefined one means you are violating the rules. Okay,
Okay.
by creating traces, your spacing is too low or too small or too nearer to the another trace means there is a chance for an accident. For example, in a road there is a uh, some of the car from the forward direction is entered into the reverse direction lane. Okay, you can understand like that only in traces,
Yes.
like that only in the traces. There is a two different current carrying in two different traces. Okay, once
Okay.
when the spacing is too closer, there is a uh, noise occur between them. Okay, noise means nothing but a crosstalk. Crosstalk is nothing but a interference between two traces which occurred by the less spacing between the traces. Okay,
Okay, sir.
and the short circuit also be occurred. Short circuit is nothing but a the two signal get mixed means there is a error will be produced. It causes the short circuit means the board get shorted. Shorted means uh, off, get off. Okay, you can understand this spacing parameter,
Yeah.
guys. Anybody others?
Yeah, yeah.
Yes,
All
understood.
okay.
Yeah. So only, sorry guys, if you have any inconvenience means tell me, because why I am telling the basic scenario means then only you can understand easily. Okay. Then it does not forget you forever. Okay. You can remember it until the end. Okay. So only I am giving. Okay. Next one is length. Length you can consider as a length. Okay. Length means the length of the highway. Okay. For example, length of the highway. Length means it is a 1 kilometer, 2 kilometer. Likewise, it's a in traces also there should be a measurement, which means the traces in PCB. I also mentioned that what is the uh, uh, connecting. One second, guys. What is the uh, count in PCB? You can recall what parameter we can measure in scale. We can measure it as centimeter above millimeter, but in PCB we can use the maximum in
Yes.
yeah, in order to if you can't able to maintain in means we can use as a mil. Okay, 1 is equal to I will show you. Wait. Guys, it's visible. Huh?
Yes, sir.
Guys, take note on it because it is more important. 1 is equal to 39.37 mil. Okay, 39.37 mils. Okay, get note it because some of the design, some of the data sheet consists of only mils, no Okay, in order to calculate them, you want to take what is the value of 1 mil. If you have 1.5 means there how much mils should be contained. Okay, these are all the basic thing. You want to note it. Okay, next, other than that, one second, guys, I will return to the PPT. Okay, you can see the PPT.
Yes, sir.
Yeah, where did you left? Length. Okay. Here the length is nothing but the total length of the trace. Okay. Length means in the total Length, which means once again the length of the trace can affect the signal integrity. Yeah, you can once again, guys. There is okay. Here the length, integrity. You can guess the meaning of integrity, signal integrity.
No, sir.
I will tell you. Signal integrity means the term where how signal can be reach out throughout the board. Okay, reaching throughout the board. For example, how the signal can be delivered at the signal for the component one to last component of the board. Okay, that it's be a analyzing of the signal. Okay, here if the length can be differ, in case the length can be high compared to the normal fixed one, there is the signal integrity gets low. Okay, there is a error in signal integrity, so the signal cannot be provided properly throughout the board. Okay, for example, you have a car. Okay, in the car you have only 10 liter diesel. You have mileage of the car is 20. Okay, how can you travel? Up to 100 kilometers you can travel. Okay, 10 cross 10 100. In order, if you have if you want to travel for your traces, you created a trace for 15 kilometers. I'm only telling this incident for your understanding only. Okay, guys. uh,
Okay.
if you draw a trace of 15 kilometers or 15 mm, consider it as a mm 15 mm, then it can't able to travel further 5 kilometers. Okay, so this is the concept. Okay, if you create a more length of the trace, means there is a lag in the signal. Okay, signal integrity, because the signal get want to travel from one end to another end for a long time without any uh, pad interaction. Okay,
Okay, sir.
these so only we want to place a main focus on the length of the traces. Okay, so only we want to select short traces. Short traces is nothing but a once the component get placed means place the another component with nearly where there is a space. Okay, here, by providing these type of short traces, we can reduce the signal integrity. We can not reduce, we can improve the signal integrity, which means signal integrity means nothing but a delivering of signal through the board. Okay, as long
Yeah,
as
okay, so
yeah,
how to work on this?
yeah.
How to overcome this?
How to overcome is I am now only says that see listen clearly. Okay, to overcome this, we want to provide a shorter trace. Okay, shorter
Yeah,
trace.
okay, that's I can understand. Shorter trace.
Okay,
If the PCB board is very length and high component is the needs, what can I do?
yeah, Satyamurthy, yeah, right.
Yes,
Okay,
the PCB board is
because for example, wait, I
very
will
large.
wait, I will tell you. If the board is very large means there is a lot of
Uh,
component. Okay,
yeah, a lot of components. Sir. How
one
can
one
I fix
wait
the
wait wait
shorter?
wait Satyamurthy, I will tell you. uh, One component is not only connected with only one component. Okay, the signal, the
Okay.
for example the TDX is a signal. Okay, trace from it is connected to
Okay.
the connector 1 to a resistor, capacitor, IC's pin 14, and another IC's pin 12, like that all. Okay, this is the one connection between all the components. Okay, in order to reduce the long traces, we want to connect the
Okay.
connection between these. For example, first we want to connect connector pin 1 to resistor, and resistor to IC pin 12, and IC pin 12 to next IC pin 20. Okay, these, by providing these, there is a no longer trace providing. Yeah, you can understand.
Yeah.
Okay, these and all techniques to overcome signal integrity, provide maintain a signal integrity. At the same time, a longer trace can introduce a signal loss and distortion. I also mentioned that signal loss can be occurred. Why the signal loss is occurred? Because the impedance, which means the impedance means nothing but a force. Okay, force means power of the signal, strength of the signal. Okay, here why it is a large. Okay, the trace is more longer means there is a need of more energy, more signal to be provided in the trace. Okay, for the if the force get increases means then only it can travel the throughout the trace for the same pressure. Okay, you can understand. Without any external or extra
Yes.
extra pressure, there is a no signal should be properly delivered. So only lengthy traces should be avoided or should be maximum avoided in the worst cases. Okay, guys, you have any doubts or you clearly understand this?
Yes, sir. Understood.
Okay, okay,
Yeah, I can understand.
okay. Next one is consideration in design. Okay, what are the consideration in design means for trace? Okay, while creating a while providing a trace between one component, which means while providing a routing. Okay, routing means nothing but a PCB routing, which means connecting a component from one part of the component to another part. Okay, we want to consider as a first one is a current carrying capacity. First, you want to calculate the current carrying capacity of the traces. How to calculate the current carrying capacity? Anyone?
What's the asking? And carrying capacity.
Yeah, current. Okay. Okay, I will tell you. Current carrying capacity determines the trace width, which means, for example, I also before I mentioned that for a first 2 days class, if it is a power signal means it should require more voltage, so more trace width. Yeah, can you remember,
Yes,
guys?
sir.
Yeah. For a
Yeah, yeah.
voltage, it should be the trace width is maximum. For a normal signal, the trace width should not be. So there is no need of wider trace width because the normal signal has no that much signal should be carried. Okay. In order here also, the current carrying capacity of the trace is determined by the how much current the trace can be carrying. Okay, for example, ampere. Yeah, you know the current based on the ampere, how much current means there is a trace width should be calculated. Okay, for example, it should be a higher voltage trace means the width should be differ. That only mentioned here. Current carrying capacities plays a major role in determining the trace width. Next one is signal integrity. Before that, I will mention that what is signal integrity. Okay, here they also consider the factor like impedance matching and grounding to the ensure the signal transmitted accurately without any interface. Here you want to understand that impedance matching. Okay, impedance matching is nothing but I also before I mentioned that what is mean by impedance. Yeah, pressure for your for your understanding term I would notice it as a pressure. Okay, I will show you what is mean by pressure in uh, generic term. Okay, guys. Okay,
Okay.
Yes.
one second, I will show you, then only you can understand what is the term. So here you can see that impedance matching in PCB design ensure the source, the transmission line and the load impedance are matched, commonly to 50 ohm, to maximize power transfer and minimize signal reflection. Okay, ringing. It is on the electromagnetic interface. Okay, it is nothing but here you can understand the transmission line and load impedance are matched, which means for example source to destination. Okay, you can mention that source to destination, it provide the impedance are matched, which is nothing but a there is a characteristics which mean as a impedance from source to destination, and it ensure that the it minimizes the signal reflection. Signal reflection means here what is meant by signal reflection means it should be a noise. Okay, noise here. It is used to minimize the noise and electromagnetic interference, EMI. Yeah, you can understand EMI. Why it is EMI is produced because of the uh, noise. EMI produce majorly the noise which affects the traces. Okay, and also providing the reflection of the from reflection in a signal. Okay, you can understand.
Yes.
Okay, this is only I am telling about that. The common technique include the controlling trace geometry with thickness substrate, and also here it is why let us see in our slide. Okay. Guys, at the same time signal integrity. Okay, it is nothing but why signal integrity, impedance matching. Yeah, impedance matching and grounding. Guys, grounding you can recall why grounding is essential in PCB design, because in order to reduce the noise. Okay, if there is a excess of current it should be carried in transmitted in traces, means the external current get directly absorbed by the ground plane. Okay, grounding is nothing but there is a plane separately act in PCB. In that plane, the grounding should be happened. Okay.
Yes. Okay, sir.
By these two techniques, the signals could be transmitted accurately without any interference. Okay, impedance matching and grounding. Okay, these are the main characteristics of signal integrity. Other than that is electromagnetic compatibility, EMC. Okay, in that trace placement and routing are crucial for minimizing electromagnetic emission and susceptibility to external noise, ensuring the PCB functions reliability. Here you can understand why the EMC is using, because in order to minimizing the electromagnetic emission. Electromagnetic emission is nothing but it is also a noise. In order to reduce that, we are providing the EMC. Okay. Prevent the traces and the signal from the external noise. Okay, these are the things. Next one, let us see importance. Why the traces are providing. Here you can see that what are the why you can see that the traces from one component to another component. Right?
Yes, sir.
Okay. Let us see what are the importance essential for the PCB functionality. I also mentioned that what is the function of traces. Okay. So only we are providing that here. And next to importance, impact on performance, because the traces can only improve the performance of the board. For example, I also mentioned that trace width, spacing, and length. By these three combination, we can achieve the effective. Effective precaution. Okay, effective precaution, nothing but precaution, effective way of transmission. Okay, you can understand.
Okay. Okay, sir.
Let us consider for the pad. Okay, guys, I also mentioned that what is mean by pad for the first two classes. Yeah,
Yes.
I will clearly show that here it is the sorry, here it is a light yellow area. Yeah, you can see
Yes, it's big.
these are the pad, guys. Okay, you can understand.
Yes, sir.
these are the pad. For example, consider it, you have a, you want to implement a, for example, consider it like as there is a large electrical towers, which carries the up to 5 wires in one like a star shape. We can see that for which carries a current from one district to another district, like and all. In
Yes,
a,
sir.
yeah, like which consists it is a looks like a transformer in big size, which is like a star shape or any other transformer shape. Here, which is constructed with the placement of iron bars. You can remember across the roads or agriculture field areas. Not as
Yes, sir.
now. For that, you want to create that transformer. First, what are the things you can measure? Main thing is the basement. Okay, there is a four standing area of that transformer is there.
Yes, sir.
Like that only. We want to uh, place a component in these stands. Okay, these yellow color pads are a conductive material, okay, which can be provided, which can able to transform the signal from these pins to the
Under.
pad, and also the pad carrying the current from another pad to the trace. You can understand.
Yes, sir. Understand.
These look, for example, it is a helipad, okay? For example, it is a helipad. The chip is act as a helicopter. When the helicopter, that means chip can be placed in that pad, then only the functionality of the chip can be completely work, okay? Guys, you can understand?
Yes, sir.
Yes.
Guys, anybody have any doubts regarding this?
No, no doubts, no doubts.
Other than
That's
Srikanth?
why in pad that one
Yeah,
point
yeah,
is there, no?
I will tell you. For I asked that, what is the role of pad? Is Aldoni clear?
Yeah.
I'll read you. A pad is a exposed area of metal, which means it is a conductive layer, usually copper, where the component lead is soldered. I also mentioned that component lead is be soldered. Once the component get placed in that pad, okay, the pads. First of all, guys, you can understand why we are using data sheet for the component creation, because the data sheet consists of what are the width of the pad. Okay, for example, there it is a first pin. Okay, here it is a first pin. The we want a pins width and a length for creating a pad. Okay, by these information of the pins length and width, then only we want to create a pad, because in order to provide a proper shape, we mismatched sometime. Okay, once you want to, it is the consider it is a 1 mm length. Okay, you are providing a 0.7 mm, means the pad get shorter. Okay, so the pins are placed some outside or can't able to be placed properly. Okay, so only want to provide a proper input for the pad creation, which means length, width, and the spacing between the two pads. What is the name? Srikanth, you don't tell. Another one, any other have any idea? The spacing between two pads, it's one name I already mentioned.
Spacing.
No,
Pitch.
pitch. Gokul, right.
Yes.
Okay, good. You can have a short point. Okay, it's a pitch. Okay, pitch means nothing but a spacing between pad 1 and pad 2. Okay, the pitch should be mostly same. Okay, here pad 1 is 1.27. Maximum the spacing is 1.27. Okay, 1.27 mm. 1.27. If the pitch is 1.27, here also the spacing is 1.27. Okay, so the spacing is not differ. Okay, this is the main area. Another one is that the pads are along with the traces. Okay, if the pads is here, means if there is a connection, each pad should be connected to the trace. Like this and all. Okay, at the same time, along with the trace, the fundamental building blocks of the electronic components. Okay, Once the pads are footprint, okay, pads and footprints are same, okay. Guys, you can understand pad and footprint is not differ, okay. Footprint is for entire component, okay. These collection of pads is known as footprint of the component, okay. Footprint is nothing but it is a foot of the component, print here, footprint, okay. No issues, you can understand like this, okay. Guys, understand, huh? Guys, hello. மாமா ஃபோன் எடுமா, ஃபோன் எடு, சார்ஜ் போட்டு விடுறது. சரி, இதுலேயே சார்ஜ் போடு. அதில் சார்ஜ் போடுமா, பவர் பேங்க்கில். ஆன் பண்ணு. Guys, sorry, there is some network issue, okay. Now you can hear me, huh? Hello.
Yes.
Okay, let us see. I tell you that it is a foot of the component, yeah, right. It is a foot of the component. Here we want to place, okay. It's a single pad. Collection of pads is called as a footprint. Footprint is nothing but a entire pads, okay, of the component, where the component.
Voice is not audible.
Now it's audible.
Yes.
Okay. Footprint is nothing but a pad is one pad, where the pad for one lid, yeah. Collection of pads is called as a footprint of the component,
Okay.
Footprint of the component, okay. Nothing but here we want to see that imagine the pad as a little landing zone, yeah. This only I will I will explain you clearly, okay. Imagine a pad is a little landing zone of the component's leg, okay. These are the legs of the component, where the pad is a landing of the leg, okay. It's like a slippers, okay. The component lid is placed on the pad, okay, here, and solder. Once the pad legs are placed in the pad, then we want to paste a solder paste and get solder here, okay. Then there is a connection will be occurred after the component placement, okay, creating a strong electrical and mechanical connection, okay. By providing soldering, we can able to provide a electrical and mechanical connection, okay. You can understand here what is mean pad.
Yes.
Okay, functions. For example, connecting components, pads provide a physical and electrical interference between the components and the PCB, yeah. You can understand this point, which means pad providing a electrical, which means the pads are done in a electrical conductivity material, yeah. Then only we can share the transmit the signal, yeah. That's only we are mentioned that, which means electrical and physical means nothing but by placing the component in the pad only we can able to solder. By providing solder only, the physical interference between the component and the PCB should be occurred, okay. There you can understand.
Yes.
Yeah. Soldering points means they offer a designated area, yeah. I also mentioned that in that pad only we can able to solder, yeah. Anybody, why, that's a reason.
It's
Guys,
having copper.
yeah, okay, okay, guys. For example, uh, the PCB, why in the green color, guys? Anybody? The why the green
It's
color?
a, it's a insulating lacquer kind of a thing coated to
Yeah,
avoid the conductivity to prepare a what you call insulated layer.
yeah, insulator layer. It is named as a solder mask. Okay, green color area. It is also provide soldering joints. Okay, provide means only by providing solder mask we can only solder the pads within the area only. There is a no any other area should be soldered across the pad. Okay, the green color area solder mask prevent that. Okay, that only providing here. That only given here. Okay, they offered a designated area for the soldering component legs. Okay, it provides us for the component leg is oval shape means only providing the oval shape only for the soldering. There is a no if you have provide more paste on that oval and you provide more lid also you can the lid not placed in the outer circle of the PCB. Okay, outer circle of the pad. Okay, you can understand only the oval shape only be get physically connected. Okay, you can understand and ensure the proper alignment and reliable connection. These are the next. Okay, heat dissipation. Heat dissipation is nothing but the metal areas of the pad helps to heat dissipation from the solder joints, which means nothing but while providing a solder, there is a heat will be produced for the component lid. Yeah, in order to dissipate the heat from the solder, the pads are providing an extra surface to providing the heat to mix with the environment. Okay, you can understand.
No,
Wait.
sir. Can you explain?
Okay, Google. Okay, Google. Wait, wait. Heat dissipation means nothing but the heat can get evaporate or dissipate through the surface. Okay,
Okay.
which happen by, for example, you have a component lid of 1 mm. Okay, for example, I show you here last page. Yeah, you can see this. See the picture.
Yes.
For
Yes.
example, the length here, the length is 2 mm. You guess it is
Okay.
not accurate. Guess. Okay. You are providing only 1 mm means it's enough for the soldering. Yeah. 1 mm
Yes.
means only
One
here.
is enough.
Yeah. 1 mm
Yes.
is enough for the placement. But if 1 mm means here means once you get paste in this area and get solder means
Yeah.
the full of area or get solder there is a no evaporation of heat can be occurred. Evaporation is nothing but a dissipation of heat can't be possible. Okay,
Yes.
in
Okay.
in order to avoid these constraints so only the pad size is give uh, enough. Okay, by this area you this part until this part you get solder means there is a some enough area are there to dissipate the heat from the solder joints. Okay,
Okay.
you now you can understand.
Yes.
Okay, heat dissipation on the solder joint. Okay, guys. Connecting pads. Okay. PCB pad design constraint consideration. Pad design consideration means what are the considerations should be we want to done during the design. Okay, guys, you can understand. Which means what are the parameters we want to check during the creation of pads. Okay.
Okay.
Okay, guys, 1 minute. Guys, now it's audible. Hello.
Yes, audible.
Yes, sir.
Okay, okay. Let us see what are the consideration of designing pads. Okay. Here, size and shape. Okay. Size and shape is nothing but size means which is nothing but a axis like x and y. Okay. X and y is nothing but in x axis how many should be provided for the pad, and y axis how many centimeters should be provided for the pad. Okay, that only named as a size. And the shape means nothing but the pads have a different types of shape. Okay, I also mentioned that circle, oval, rectangle, rounded circle, like an rounded rectangle, like and okay, diamond. Okay, based on that we can um, based on that we can differ. Okay, here also that only mentioned the pad size depend on the component lid diameter and desired solder joint strength. Okay, if the component pad has like needle, yeah, which means like through hole pin. Okay, guys, you can hear me? Hello.
Yes,
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 sir.
we can hear.
Okay, okay, okay. If, for example, uh, the component lid means the pin of the component is like a square shape means which shape will be provided for the pad. In case you have any guess?
That is the first pin or
For no, no, the pin like the previous image I will show you. Okay, I will explain you. For like that we are using square shape. Okay, square or rectangular maximum. Maximum is rectangle, not square. Okay.
metal. Yeah.
A rectangle shape paddings will be provided. In most cases, there should be a in most cases there should be a placement of uh, rounded rectangle. Yeah, rounded rectangle is nothing but a edge of the rectangle should be curved. Yeah, you can guess that shape. Yeah,
Yes, sir.
rounded rectangle. In some case, there should be a oval shape. Yeah, oval shape is nothing but like similar to the ellipse. Okay, that shape. Based on the component lid, the shape should be differ. Okay. Okay. Second one is plating. Plating is nothing but a soldering. Okay. Pads can be plated with additional metal like tin or gold to improve the solderability and prevent oxidation, which is nothing but not a soldering. Plating is nothing but providing an external coating to the pads. Okay. Once you provide the external coating over the pad, it should be improve the solderability and prevent oxidation. Oxidation is nothing but a like water. It should be a evaporation. Okay, you can understand what once we boil the water get
Yes, yes,
evaporated.
yes.
Once the water get boiled, the water get evaporates. Like that only, the copper also get evaporated, not evaporated, oxidized for a long time after. Okay, so preventing this, we want to plate that pad means the plating prevents the pad from the oxidation. Okay, annular ring.
Okay, sir.
Annular ring is a additional component, additional parameters which guard means which protect the pads. Okay, annular ring. The area surrounded by the pad often keep clear and copper trace to prevent accidental shorts. For example, it act as a boundary for the pad. Okay, it is placed around the pad. Okay, surround the pad often keep clear to the copper. It is something, but once it is placed, there is no any other copper trace should be connected. No any other copper set should be connected. Okay, it should be act as a preventing agent to the pad. Okay, and
Okay.
preventing from the accidental shorts. Accidental shorts is nothing but a connection of Any other two traces or two pads? Okay. Okay. Other than that, through hole pads. Okay. For example, guys, I want to uh, give you some of the area. Okay, means via in pad. Via in pad is nothing but we want here it is nothing but placing a via in pad. Okay. Uh, via is I also indicate you. Via means vertical interface axis. Okay. Vertical interface axis is placed directly in the pad in order to reduce the uh, uh, reduce the board size. Okay, for example, for for example, if you place the via in here means, okay, if you place the via in here you can't able to here you can able to create a connection, but there should be a some of the trace from here to is top, bottom, again top. So why placed here means you can directly connect to the another via. Okay, you can understand. This is mainly focusing for reducing the board size.
Please explain it again.
Yeah, yeah, Ajit.
Yeah, the VF pad you explained, right? But again, can you please explain it?
Okay, Ajit. It is nothing but via in pad is while you placing the via in the pad itself. Okay, you directly connect the pad to the another area. For example, the wire gets connected to the backside means, for example, okay, the wire is connected to the for example, consider it as a top layer. Okay, there
Okay.
is a bottom layer also having a trace. Okay,
Okay.
once you place a wire in the pad, the connection also get under this pad. Okay, then you can easily connect with another component directly by using another wire. If you, for example, you want to place the wire in here means, okay, the area
Okay.
is should be wasting. Okay, for example, if you have placed the wire in here and you want to take a trace from here and connect the wire, and you want to connect the wire from another component or another wire. Okay, in order to reducing these spacing issue, we want to we are providing via in pad. Okay, you can understand.
Okay, Avinash.
Okay, are you Tamil, Ajit?
Yeah, yeah.
அஜித் ஒன்றும் இல்லை அஜித். இப்போ பார்த்தீங்கன்னா நீங்கள் வந்து இங்கே ஒரு வயா வைக்கிறீங்க, ஓகேவா?
Okay.
நீங்கள் இங்கே இருந்து இந்த வயாக்கு கனெக்ஷன் கொடுத்து அந்த வயால இருந்து இன்னொரு வயா கொடுத்து இன்னொரு காம்பனண்ட் கொடுக்கணும், ஓகேவா? மேக்ஸிமம்
ஆமாங்க.
வயாவோட ஒர்க்கிங் இது என்னது, ஒர்க்கிங் இது எதுனா டாப் லேயர்லேருந்து பாட்டம் லேயர் கொண்டு போகிறது, பாட்டம்லேருந்து டாப் கொண்டு போகிறதா? ஃபார் எக்ஸாம்பிள்
ஆ.
வச்சுக்கோங்க, இது வந்து டாப்பில் இருக்குது, நீங்கள் பாட்டம் கொண்டு போகணும், ஓகேவா?
ஆ.
அப்படின்னா இங்கேருந்து எடுப்பீங்க, ஒரு பாட்டம் வயாக கொடுப்பீங்க, ஓகேவா?
ஓகேங்க.
இங்கேருந்து ட்ரேஸை எடுத்து பாட்டம் இங்கே ஒரு வயா கொடுத்து அந்த பாட்டமில் எடுத்து இன்னொரு வழியை இன்னொரு பாட்டம் ட்ரேஸ் வழியை எடுத்து மறுபடியும் இன்னொரு வயா போட்டு மறுபடியும் டாப் லேயரில் வந்து கனெக்ட் பண்ணுவீங்களா? அதாவது உங்கள் ஒரு டாப் லேயர் இருந்ததுன்னா உங்களை கிராஸ் பண்ணுறதுக்கு இதுதான் வழி, ஓகேவா?
ஓகே.
இதை வந்து நம்ம ஈஸியாக முடிக்கிறதுக்காக பேட்லேயே நம்ம கனெக்ஷன் போகிறதுனால நம்ம இந்த பின்னோட சிக்னலை நம்ம டேரெக்டாக இந்த பேடில் இருந்து கிரவுண்ட் பிளேனுக்கு எடுத்துக்கலாம், ஓகேவா? கிரவுண்டு பாட்டம் சைடு ட்ரேஸ்க்கு எடுத்துக்கலாம், பாட்டம் ட்ரேஸாக எடுத்துக்கலாம், ஓகேவா?
எப்படின்னா அந்த விஆர் பேட் வந்து பேட்ல இருக்கு, அது டைரக்டா வந்து அதர் சைடு பாட்டம் சைடு போறது.
அவ்வளோதான், அந்த மாதிரி தான் அதோட வழி.
இல்ல, எனக்கு என்ன டவுட்னா இப்போ அந்த ட்ரெடிஷனல் வயா ஒன்று போட்டிருக்கீங்கல்ல?
ட்ரெடிஷ்னல் வயானா நார்மல் த்ரூ ஹோல் வயா, ஓகேவா?
ஓகே. நார்மல் த்ரூ ஹோல் வயா, இது அதர் சைடும் போகும்ல அந்த இது ட்ரெடிஷனல் வயா?
ரெண்டுமே ஒரே ரெண்டு வயாமே ஒரே மாதிரி ஒர்க்கிங் தானே?
ஒரே ஒர்க்கிங்க. உங்களுக்கு பிளேஸ் வயால வந்து பேட்ல வந்து வயா இருந்தால் என்ன எது எப்படின்னு சொல்றதுக்காக அதை போட்டுருக்காங்க, ஓகேவா?
ஓகே ஓகே
ஓகே.
ஆமாம், ஓகே,
தேங்க்யூ.
ஒன் செகண்ட், எல்லாம் மியூட் பண்ணிக்கோங்க, ஓகேவா? நெக்ஸ்ட் ஒன் வந்து த்ரூ ஹோல் பேட்ஸ். த்ரூ ஹோல் பேட்ஸ்னா நத்திங் பட் தீஸ் ஆர் த மோஸ்ட் காமன் டைப் டிசைன் ஃபார் த காம்பனன்ட் வித் லீட்ஸ் பாஸ். அதாவது த்ரூ ஹோல் பேட்ஸ்னால் என்னென்னா ஒன்றும் இல்லை. இப்போ நம்ம நீங்கள் guys, sorry, okay, while you are creating projects in your engineering field, okay, which means BEE, basic EEE, yeah, you have a lab session, there you have providing a ICs, okay, in there the ICs are having a through hole, okay, through hole there is a lid, okay, which you want to place insert the ICs in the breadboard or any other folder. Yeah, you are right. Like that only. You want to, for example, I will show you. Oh, guys, you can see the screen now. Here, hello.
Yes.
This is a through-hole pads, which means where the components leads are directly placed, inserted here, okay, inserted here and soldered at the bottom end, okay, here like this and all. For example, I will show you here. Yeah, you can see that here there it is a Q6 is a transistor, okay. It just 3 pins, which where the 3 pins are here and where the 3 pins are inserted in these pads and soldered at the bottom. Okay, now you can understand what is the through
Yes,
hole
sir.
pads. Okay, okay guys, now let us enter into the. Okay, okay. Next one is sill screen. Okay, guys, sill screen. What you have any idea about sill screen?
Component like
Reference.
identification mark, which will
Yeah,
be in white color above the mask layer.
yeah. First of all, sill screen is nothing but it acts as an indicator for the component. Why should want to indicate the components name? Because in assembly process we want to identify where the component should be placed. Yeah, Ratnapriya, are you here?
Yes, sir.
You have you can able to reach me.
Yes, sir.
Okay, okay. If you have any doubt, means ask like um yeah, like
No,
Gokul.
no, sir.
Okay,
I'm
okay,
going through
okay. If you have
various parts.
okay, okay.
Yes.
Take notes on that if you have any doubt. Okay.
Okay.
Okay, for guys, what is mean skill screen means? Skill screen is nothing but once you have to ensure that skill screen is a act as a uh, uh, designator, which means it will act. For example, I will also show that like last image we see. 1 second, guys. It is okay. Yeah, like here. Question, sir. Is visible, Dana? Here, here there is a white line, yeah, where the components is placed. Okay, hello guys.
Okay, sir.
It is the white line. Here, for example, it is the white color area. Within that, the transistor should be placed. Yeah. Why we want to mention that? There is a two reason. Srikanth, you don't give chance to some others. Guys, any? There is a two reason why we are using this sill screen. Two are similar. I will tell you. Here, the sill screen's purpose is, for example, it should be act as a like parking. You have seen that in a parking for like malls, any other restaurant, there should be a car parking area, there is a four corners should be marked. Yeah, you can remember that. Hello, guys. Hello, you can. Phone tomorrow. Guys, now it's audible. Huh? Hello.
Yes, audible.
Audible, sir.
Okay. Sorry for the disturbance. My internet gets some delay. Okay. Okay. Let us see what is mean by still screen. Yeah. Now the screen is visible or not? Okay. There is no visibility. You can see. Mm. I will told you that what is mean by you can see that the car parking in the mall, restaurant, etc. Yeah. Have you seen that, guys? Hello.
Yes, sir.
Okay. Respond me. Then only I will interact the class more. Okay. For example, you can see the mall. There is a car parking. There is a square shape area, which means the particular car should be placed in that square shape. Okay. You can understand. There is a box shape, which means in a rectangle shape. In that, the one car should be perfectly parked. Yeah.
Your voice is breaking.
Uh, Now it's audible, huh? Guys. Now, hello, guys. Now it's audible, huh? Hello, hello, guys. Now it's audible, huh? Hello, somebody respond me. Hello, guys. Hello, guys. It's visible, huh? Hello. You can remember what is in my drills.
For
Who is
true quotes.
okay, drills. First of all, that before that, we want to ensure that sill screen. What is sill screen? Sill screens are the area where the component should be placed. It is looks like a white color region. It is a boundary for the component. Okay. It also mentioned the name and the number of the components like this. the white color area is known as skill screen. Okay, there is any other doubts in a skill screen, guys?
No, sir.
No. Okay, okay. Next week
No,
directly
sir.
enter in the drills in PCBs. Okay, drills. I also mentioned in class one or class two. I don't recall exactly, but drills are mainly yeah, a mechanical activity. Okay, PCB drilling, which is known as PCB design. That means printed circuit board drilling is a process of creating holes, slots, or other cavity in an electronic circuit board. Okay, these cavity that means the cavities which are created by the drilling is mainly used for the vias or creating pads. Okay, through hole pads. Okay, you can understand, guys. Hello, guys. You can reach me. Huh?
Okay.
Okay, it is nothing
Okay,
but
sir. Understood.
once you are for example, it should be a via or
Yes,
a
sir.
pad. Via or a pad. Okay. Via means you know that vertical interface axis. You want to drill a hole in a pad. Okay. Okay. Drill a hole in a pad. That's the same thing for a creating a through hole pad. Once you want to drill a board, then only you want to create a plating in that hole. Okay. Once you complete the plating, then only it act as a conductivity hole. Okay. Guys, you have any other information? You need any other information about the drilling? Huh? Because for example drilling in drilling the diameter is most important for the drilling. Okay, for example I also mentioned that before I mentioned that um, for example the lid of the component is 0.2 mm. You want to create a hole for 0.2, at least 0.22 or 23. Okay, because the exact pinning exact component lid shape we can't able to create. Okay, based on the data sheet you want to create input provide the input for the drilling area, then only you want you have you
No,
give.
sir.
Okay, then only you get a perfect hole size. Okay, then only you can't able to insert a component into that through hole pad. Okay, and then you get mm, soldered at the bottom. Okay, you have any other doubts? Here there is a sum of the drilling guidelines. It is mainly entered into the uh, PCB manufacturing, so it does not want this. Okay, okay. Manufacturing process of PCB drilling. It also considered it as a okay. It is final stage, which means solder mask. Okay, guys. You remember few hours, a few minutes before I mentioned that what is solder mask? Yeah, guys. Guys, you can remember. Hello, are you in the line? Hello, guys. Respond me. Yeah, guys. Guys. Sorry, I will share my screen. Okay, guys. Few minutes ago, I will discuss about what is mean by solder mask. Yeah, you can understand. Why the board is in green color? Yeah, I will explain you what is the purpose of PCB board. Okay, what is the purpose of solder mask in the PCB board? Okay, solder mask is a coating, which means which applied in the top layer or bottom layer of the PCB. Guys, mute your mic. Who is this? Mm, Satimurthy, mute your mic.
Yes, sir.
Okay. Example. Here, as a few minutes ago, I will explain you. It is a layer which is applied in the top of the PCB and bottom of the PCB. Why you are placing the solder mask means, for example, you can see I mentioned that few minutes ago, water get evaporate. Like that only, copper also get get oxidized. Okay, oxidized is nothing but a it can reduce the it can lose the uh, property of the copper. Okay, while the copper get oxidized means the conductivity of the copper also get reduced. Okay, uh, in order to prevent that we are providing the solder mask, which means nothing but what is the chemical formula for the copper? Cu2.
You.
Cu. Hello guys. Cu.
See you.
Only CO, only CO.
Yeah, only Cu. Okay. Only Cu. If there is a oxidation is when the copper get oxidized, the copper will be changed. Okay. In order to prevent these oxidation, we are providing the solder mask in the top and bottom layer of the PCB. Why we are placing the solder mask only in top and bottom layer means because these two layers only visible to the surrounding. So only we are providing solder mask because the inner layers are not visible to the any surrounding. Okay, you can understand the concept of because top and bottom layer are the most main layers which are most chances for the oxidation of the copper. Okay, guys, you can understand.
No, sir.
கோகுல், உங்களுக்கு வந்து எப்படி சொல்லணும்னா காப்பர் வந்து அதோட தன்மையை இழந்துரும். ஓகேவா?
Okay.
அதோட சுற்றுப்புற சூழல் அதாவது உங்களோட சரௌண்டிங்கில் இருக்கிற டெம்பரேச்சர் ஆர் எனி அதர் கெமிக்கல் ரியாக்ஷன்ஸ்னால காப்பர் வந்து கொஞ்ச நாள்லயே அதோட கண்டக்டிவிட்டி அதோட ப்ராப்பர்ட்டியை இழந்துரும்.
Properties. Okay, sir.
ப்ராப்பர்ட்டியை இழந்துரும். இப்போ அந்த டைமில் நீங்கள் மேலே சால்டர் மாஸ்க் போடுறப்போ அதோட ப்ராப்பர்ட்டி வந்து அதுலேயே இருக்கும். அந்த கெமிக்கல் ரியாக்ஷன்ஸ் எதுவும் நடக்காது. ஓகேவா?
Okay.
காப்பர்
Okay.
ஆக்சிடைஸ் ஆகாது. அதுக்காக தான் நம்ம சால்டர் மாஸ்க் மேலே க்ரீன் கலரில் போடுறோம். உள்ள
Okay.
நம்ம இப்போ இதே உங்களுக்கு 6 லேயர் 8 லேயர் இருக்குன்னா நீங்கள் ஏன் டாப் பாட்டமை மட்டும் போடுறீங்கன்னா இன்னர் லேயரில் வந்து உங்களுக்கு எந்த ஒரு ஆக்சிடேஷனும் நடக்காது.
Okay.
ஓகேவா? ஏன்னா அது சரௌண்டிங்கில் வந்து உங்களுக்கு படாது, வெளியே பக்கம் படாது, என்விரான்மெண்ட்டில் படாது.
Okay, sir.
ஓகேவா கைஸ்?
Okay.
Okay. Let us see the second point. Okay. Exposed protection exposed copper from the oxidation environment corrosion. Okay, this is the second point. Third point, preventing solder bridge from forming between closely spaced pads during the assembly. Guys, for example, there is a two components which is placed near, which means that there is a two resistor. Okay, R1 and R2, which has the same values also, which is placed nearly. Okay, once you have soldered these in your bare hands means nothing but hand soldering. Okay, once you get a solder in hand soldering means once you paste the solder and you want to place means without the solder mask the solder get applied both in two pads. Okay, you can understand the Ratnapriya, you can understand if there is a two components. Okay,
Yes, sir.
two resistor which is located parallelly located means once you apply the solder at the one pad end. Okay, consider this. Okay, these two dots. Okay, wow, consider the two dots. Yeah, you can visible two bullet
Yes, sir.
points. Once you have placed solder paste at here, and you want get solder means here the white space, yeah, you can see, yeah,
Yes, sir.
the white space without solder mask. While you get solder means the solder ion get ion connect with this pad also, okay. While providing a solder mask, it acts as a bridge between a barrier between two pads, okay.
It
Barrier,
separate.
yeah, yeah. While you get while the ion get soldered here, the ion does not touch here, okay. Guys, in basic,
Okay, sir.
in fundamental means the lotus flower does not contain the water to spill. Yeah, it can resist in the leaf. Yeah,
Got it. Yes, sir.
like that only property of the salt mask. Okay, you can understand.
Sir, understand.
Yeah, அதோட சால்டர் மாஸ்க் இருக்கிறனால ஒரு பேட்ல இருந்து இன்னொரு பேடுக்கு வந்து ஈஸியா வந்து சால்டரிங் ஆக விடாது. ஓகேவா? சால்ட் ரெசிஸ்டன்ஸை ப்ரொவைட் பண்ணாது. ஓகே. அது தேர்ட்
Okay.
பாயிண்ட் எலக்ட்ரிக்கலி இன்சுலேட்டிங் லைவ் நெட்ஸ் டு ப்ரிவென்ட் ஷார்ட்டிங். அதை தான் சொல்றாங்க இன்சுலேட்டிங். இப்போ கனெக்ஷன்ஸ் வந்து இன்சுலேட்டிங்னா கண்டக்டிவிட்டி தடுக்கும் ஒன் பேட் டு அனதர் பேட், அலோவிங் எக்ஸ்போஸ்ட் ஏரியா டு பி செலக்டிவிட்டி கோட்டட் பை தி பிளேட்டட். அதாவது நீங்கள் வந்து பிளேட்டிங் பண்ணுவீங்கல்ல, ஒன்ஸ் யூ கெட் பிளேட்டிங் ஐ ஆல்சோ மென்ஷன் தட் வாட் இஸ் மீன் பை பிளேட்டிங். யா, பிளேட்டிங் இஸ் அ ப்ராசஸ் ஆஃப் என்ஹான்சிங் தி pads property. Yeah, enhancing the pads property for the solderability. Yeah, guys, you can understand. Ratnapriya, why we are going for plating?
Yes, sir.
Why we are going for plating process? Okay, no issue, but keep watch me, okay. What I'm saying, it is fully connectivity only, okay. There is a no அதாவது இப்போ பார்த்துட்டிங்கன்னா நீங்கள் எல்லாத்தையுமே கவனிச்சுட்டு வாங்க. உங்களுக்கு வந்து இது சரி, இதுனா ஒன்று, இதுக்கப்புறம் இது தேவைப்படாது அப்படின்னு நினைக்கிறீங்க. எல்லாருமே வந்து ஒன்னோட ஒன்று கனெக்டிவிட்டியாக இருக்கிறது, ஓகே. ரத்னப்பிரியா, நோ இஷ்யூஸ், ஐ வில் டெல் யூ, ஓகே.
Okay, sir.
Plating, why we are going for plating means the pads, okay. SMD means surface mount technology. While plating, the pad which have be the components should be placed in the pad only, yeah, right. While plating, the solderability should be increases, okay. The stability of the soldering should be increases after the plating, okay. Okay, if you have any doubt means ask me, okay. Green solder mask is mostly, yeah, the second point, the second main point is here, yeah. In the world, most of the PCBs are looks in green color because it is a solder mask which is used in globally for the basic circuit, okay. Other than that, the solder mask should be looking green, white, red, blue, etc. colors also, okay, based on the use. At the same time, but solder mask serves an important role for the beyond just looks, okay. It is not only for looks, it's also be useful for the things which were seen before, okay. When designed and applied correctly, it greatly enhances the PCB reliability and manufacturability, okay. While we are using the solder mask effectively, it should be effective for the further years and improves the reliability of the board, okay. You can understand, guys.
Yes, sir.
அதை வந்து நம்ம கரெக்டாக யூஸ் பண்ணோம்னா நமக்கு வந்து அது ரொம்ப கரெக்டாக ரொம்ப லைஃப் லாங் அது வந்து நமக்கு ஒர்க் ஆகும் அப்படிங்கிறது, ஓகேவா.
Durability. Okay, sir.
ஓகே கைஸ், சால்டர் மாஸ்க் வந்து தான் முடிஞ்சிருச்சு. இதில் உங்களுக்கு இமேஜ் தெரியுதா?
Yes, sir.
சால்டர் மாஸ்க் அண்ட் கிளியரன்ஸ், ஓகேவா. இதில் வந்து இந்த இடத்துல வந்து என்னென்னா, சால்டர் மாஸ்க்குங்கிறது உங்களுக்கு வந்து ஒரு க்ரீன் கலர் லேயர் மேலே அப்ளை ஆகும், ஓகேவா.
Okay.
இந்த black color ஏரியாலாம் இருக்குல்ல, இந்த ஏரியால இருந்தா வந்து solder mask உங்களுக்கு.
Sir, புரியல.
The sorry guys, the areas where okay, let us see. உங்களுக்கு இந்த பிக்சர் வேண்டாம், உங்களுக்கு வந்து கொஞ்சம் குழப்பற மாதிரி இருக்கும் பிகாஸ் கலர்ஸ் வந்து உங்களுக்கு வேற மாதிரி இருக்கு. வந்து ஃபர்தர் ஆன் பார்ப்போம், ஓகேவா? The solder mask is, for example, you have seen the board which is in green color, yeah, right? The green
Yes, sir.
color is known as solder mask, okay?
Okay.
Solder mask design consideration, okay? How the solder mask should be considered in PCB design, yeah? Which means the thickness of the layer, okay? Where did we want to provide keep clearance between mask and pad consistent, like and all, okay? Makeover pads size defined both the copper and mask layers, okay? These are some of the constraints which are used for solder mask, okay? Let us see in while designing, okay? For example, here you can see that, okay? What should be mask clearance be? Size should my mask clearance be, okay? Mask is nothing but solder mask relief. For look at these areas, okay? The green color area is a solder mask, okay? Thick green is a solder mask. The light green area, okay, covered, the light green area is a mask which cover the traces, okay? Traces is nothing but a copper, okay?
Okay, sir.
In the bottom image you can see that it is green color area is solder mask, the copper is in a brown color, okay?
Okay.
Yeah, okay. At the same time, it also same. The green color area is a solder mask. The area where the copper solder mask is not provided is known as solder mask relief, okay? Guys, you can understand now?
In that place, components will be placed, right?
Yes, sir. Yeah. Yeah, Gokul. Yeah. Now, let us see what are the other things. Yeah. Applying solder mask to power coating, liquid photo. No need because it is only for manufacturing buys. Okay. Types of PCB, single layer, double layer. Okay. These layers are we have seen already. Yeah.
Yes, sir.
Before that, I will explain you that how the solder mask is placed. Yeah. Here, see this. Okay. It is a single layer, which means copper. In the above to the copper, the solder mask is applied. Yeah. You can see this. Yeah.
Topmost of PCB.
Okay, copper layer, above the copper layer, solder mask is applied. Okay, this is a separate substrate. Substrate is nothing but a material. Uh, Guys, mostly a substrate is a raw material which is used for the PCB. Most of the PCB are done by the FR4. Okay, FR4 is one of the substrate where the PCB is mainly used. Okay,
Okay, sir.
the top layer and bottom layer, if it is double layer. Okay. Okay, you know that multi-layer. Yeah, this is the structure of a multi-layer, which means different layer which is connected by the direct bias. Here the light yellow, light green area is a traces. Okay,
Okay.
guys. I will also now I will explain you the structure of the PCB. Okay, guys. Note this here the core. Yeah, you can understand a core.
Your voice is breaking.
Guys, here the area is known as uh, pre-peg. Yeah, here you can see that it is a pre-prick.
Where?
Here in the area pre-prick.
Okay.
Not windows.
Guys, pre-prick. You can see, yeah.
Not windows.
Below.
Voice not audible. Guys, now it's audible. Okay. So okay, guys. This is the only content today. I will complete it, and tomorrow we can see the further rest. Okay. Here it is prepreg is a insulating region, okay, which separate the two different layers. Okay, guys, you get understand? Guys, one second. Hello.
Now it's audible, guys.
No, breaking.
Now.
Yes, sir.
Okay. The prepreg is known as insulating region. Okay, guys. Respond me now. It's audible. Hello, guys. Gokul. Hello.